Hi, everyone. Thanks for joining us this morning. I'd like to welcome you to the latest session of our weekly product webinars. During this and the next 2 weeks, we're very excited to give you a three-part AI 101 series where we will go through a quick primer on all of the latest happenings within the realm of artificial intelligence and also tell you what you need to know to become well-equipped to handle conversations about enterprise AI. To start, we'd love to go ahead and start our first session, which is focused on an enterprise generation or generative AI and an introduction to LLMs. During today's session, we'd love to ask that if you have any questions for us, go ahead and use the Q&A feature that's located at the bottom of the screen. And also at the end of our session, we're also going to have questions for you. So we'd love for you to participate in our poll as well. As a reminder, if you need to leave today for any reason, the recording will be available for you to access later on Moveworks Academy. With that, if you can move to the next slide, Matt.
Sure.
I'd like to introduce our speaker for today, Matt Mastelli, who's a machine learning engineering manager with us at Moveworks. And during today's session, we're going to tell you all about what LLMs do, how LLMs can be used to perform some of the major classification generation functions that you're actually all well acquainted with from using the Moveworks bot, and then also how Moveworks fine-tunes LLMs for enterprise applications. So with that, I'm going to go ahead and hand you over to our ML engineering manager, Matt, to take you away for the rest of the session. Matt, over to you.
Wonderful. Well, hi, everyone. Thank you so much for your time. I hope this will be very informative. So, first of all, what is LLM? Like, you may be hearing this kind of thrown around, like there's a legal term for it, like one meaning of it, but LLM in an AI context stands for large language model. But what does it actually mean? Well, let's break it down word by word. So a model is a effectively a mathematical model that takes some input and produces some desired output. And it's usually adapted to a bunch of training examples where there's a bunch of inputs and then the outputs that you want an output for those examples. So one example is here with Newton's second law of motion is an example of a model of the force that it takes to accelerate mass by a certain amount. Or in this example, like how fast will a ball move if it is kicked with a certain force, or how fast will it accelerate at least. This is an example of a deterministic model where it's, we know how it works, and we know that given specific inputs of one and the other, it's very clear what the right answer will be. But there are also examples of probabilistic models, like for weather. A weather model takes in a bunch of different features, a bunch of different input things, such as temperature on a given day, like cloud readings, the cold fronts and warm fronts and so on, to answer the question, will it rain this week? And we output basically predictions about what the temperatures will be, what the weather will be, and so on. And this is an example of probabilistic model where the prediction we're trying to do is not guaranteed, but we can do our best to try to guess what it will be with some degree of uncertainty. A language model is a type of model where the input is text and the output is text, or more specifically, as we'll see in a bit, probabilities of what text will come next. So in other words, what a language model is often being trained to do is to predict what is the next word. For example, in this input text, we couldn't enjoy the view because there was too much fog in San blank. Now, this isn't deterministic because there's a bunch of words that could go there. Someone could have done a typo and said San, New York, but most likely, it's much more likely that the answer would be Francisco or Antonio or some other city that starts with San and often has a lot of fog. And you see, language is, variable. And so there is definitely a probabilistic aspect to this where you need to be able to handle this uncertainty well, where you can't just have a rigid equation with some rigid if-else statements to say, if this text, it must be that. You have to model it more probabilistically. And this is a thing we've been doing at Moveworks for many years. And a large language model is a language model that has many tunable parameters. As an example, GPT 3.5, specifically the DaVinci version, has 175 billion tunable parameters. That's like F equals MA, but instead of, M and A, there's like 175 billion of these. It's very, not 175 billion inputs, but still lots of tunable parameters. And to get these parameters to perform this output, this capability of predicting next word really well, it's trained on massive amounts of text data. And training is basically giving it an input, expecting an output, and when it's wrong, updating all the 175 billion parameters by a little bit to make it have done a little bit better on that example. And then you repeat for the next one, the next one, the next one. And so GPT 3.5 was trained on 570 gigabytes of data, books, web text, Wikipedia, etc., where essentially, like, here is a sentence from this book. What's the next word? You guessed this word? You're wrong. It should have been this one. Update all the parameters in order to get it better next time. And again and again and again. And what it does in the process is learn some of this information in nice surprise ways that can surprise people about whoa, it seems to know, the plot of, A Wrinkle in Time and so on, because it was trained to, given this sentence, what word comes next. So large language model, to recap, a large language model is a conceptually massive model with many parameters that performs language tasks like predicting the next word, though not just that, as we'll see in a bit, and are meant to mimic real-world human behavior when given a text input. Or more recently, an ideal assistant. And this is the kind of thing a lot of companies are trying to do, is have it not just essentially predict, if you go back one slide, not just predict text that looks like what it's on the internet, which is, if it's on the internet, it may not always be the right tone, it may not always be the right content. We want to have, a big part of what a lot of companies like Moveworks are doing is training to not just predict that, but to be fine-tuned in such a way that it is being an ideal assistant, polite, correct, sticking to the truth, and so on. So Moveworks has actually been harnessing best-in-class LLMs for their unique strengths for a long time, starting in 2019, when we were using BERT, one of the original, very first large language models or I guess you could say maybe medium-sized language models, that wasn't in the billions and billions of parameters range at the time, in the size we're seeing now, for things like domain and classification, using things like Roberta from Meta, which we fine-tuned to do multilingual classification, all the way up to today, where we see some models like GPT 3.5, GPT-4 by OpenAI. And we use them for all kinds of things that don't also all use them the same way that you might think. Like today's day and age, people are thinking, okay, what these language models are doing is just text in, text out. Let's try to prompt engineer it to get it to output the right text. And then people sometimes run into issues with that. But it turns out there is if there's one thing you can take away from this presentation, it is one level deeper that is very, very useful for working with large language models. Because you can operate it at the level of just putting text out. But what Moveworks has been doing since the beginning, since at least 2019, has been using one level deeper of what these models are really doing, which has to do with these terms of embeddings, or otherwise known as vectors. And you start to see that other companies have been doing this too, to some extent, or at least are building towards this particular usage of LLMs, because embeddings and vectors are all the rage in the news if you know what to look for. For example, this company Pinecone got $100 million in investment to build a vector database. What's a vector database? We'll see. Chroma bagging $18 million to speed up AI models with an embedding database. So, but how are I thought large language models are all about text. What do we need embeddings or vectors for? Turns out it's very key to what's actually going on under the hood. So to show a look under the hood, I'm going to pop out of these slides for a second and show a little demo. So here, this is an example of one of the very first embeddings of text, which is called word to vec. You put a word, and what it does is it embeds them in a space that puts it close to other words that it's similar to. So essentially, you go from just strings of text to numerical representations that, for example, put anniversary. If you go ahead and click on one of these, very close in space to birthday, celebrated, December, celebrating, and pretty far away from examples like Fourier or cavity or other things. And eventually this algorithm called word2vec was developed quite a while ago to basically let you have a mathematical representation that models could use to do the same kinds of things with words that are very similar or like can be used interchangeably. Though what's interesting about this is that if you, for example, look at a common word in IT like file, if we double click on this one, there's something inherently contextual in our understanding of words, right? Like if you, for example, look at what word2vec does with file, its closest things are files, format, server, Linux, document, which is like pretty good. It relates to one meaning of file, but it's not the full meaning of file, right? Like you see the word file all the time used as a verb to like submit or like a ticket, for example. Or you also, if you're like in, fashion, for example, file might be like a nail file, but that's not represented here at all. And so embeddings, basically this concept of embeddings is, first of all, like this is the way I like to visualize it is, you get the idea like text is this nebulous thing, but if you embed it, you can start to work with treating similar words or related words similarly. But you also need to try to contextualize it because what file actually means is context dependent. And word2vec is an early example that was not context dependent. And what I'm going to show you today is how we can actually use large language models to make them contextually dependent and to make them be used better. So this is a concept of word embeddings that I mentioned. The representation used by models is essentially an address of a bunch of numbers of like, in this example I was showing, I was projecting it into 3D. It's an example modelers use to visualize it. The actual models are just using a series of numbers where if you imagine like the coordinates are close to each other, then they're probably pretty similar. If they're far away, then they're very different words. And for the purposes of these slides, to show what these language models are actually doing along the way of predicting text, I'm just going to show it in one dimension, where basically words get mapped to somewhere along this one line, where, for example, in this case, we have like verbs towards the top, nouns towards the bottom, conjunctions and articles in the middle. And the key idea of this representation is words that are close together on this line or have similar meaning in the context of the sentence. So in this case, this context might have file pretty close to like purchase pretty close to buy, file pretty close to submit versus not super close to request. And that can be a contextually dependent thing. So let me say, okay, why are you throwing all this? Why are you bringing numbers into this? I just want to know how to use these. Well, let's dive in to show like just for one more bit of intuition, what is language modeling actually doing? So when language modeling, you're basically putting in words one at a time, or if this words are too long, tokens, which is like a part of a word, but long story short, you can think of it like words coming in one at a time. So file comes in, it gets embedded somewhere like in the verb sense. Ticket to, where a ticket maybe gets put pretty close to request. And then it's basically assigning probabilities of all of the different words to come next based off of where they are. It's like a trajectory along this space where it's like probably going to go like to is probably due into verbs. So we're looking at verbs, and fix is more likely given ticket and file than get. And like way more likely than like potato or something like that. And also these things get updated as they go. Like at the beginning, file by itself was probably down here, but as soon as you add a ticket to, it's adjust like a large language model because of the way it's trained will adjust how it's representing them contextualized on the rest of the sentence. Now, as we're talking about contextualizing them, if you, for example, say file a ticket to, then what it'll do is it'll, for example, start predicting fix and get because ticket will be pretty close to, for example, request. But if I instead say buy a ticket to, we can see here it's representing ticket as instead of being close to request, being close to flight because you don't purchase requests, you're more likely to be purchasing a flight or purchasing a pass or something like that. And what you end up with there is when you start predicting more, you start to see like buy a ticket to the is likely, or buy a ticket to watch, buy a ticket to fly, buy a ticket to sand, which could then turn into Francisco or Antonio or other things, or Santiago, can continue into a longer word, and so on. And so now, and this is where when people say, okay, large language models are about generating text. Well, what is it actually doing? What is generating text is bit by bit using the probabilities to predict, to pick which words to use. So the language model isn't itself picking words. A program on top of it is using the probabilities output by the model to decide what to output next. So for example, if you're completing the text, file a ticket to, a program has to decide, do I pick fix, the most probable next word, or do I pick them at a probability associated with fix versus get, etc.? And this is where you can end up with different outputs from the same input. That's often because the thing that's picking what next text to do is looking at the probabilities and making a probabilistic choice. So here, if we pick, for example, the highest probability words, we'd say file a ticket to fix is highest probability. Fix, what's next? My is highest probability. File ticket to fix my. Laptop, right? For example, let me go back one, laptop's high probability, and voila, we've generated text. But you can imagine if you, for example, do something more probabilistic, you might have said file a ticket to get, and then have a whole different trajectory. And this is how you end up with different outputs for the same input, is you might have different probabilities using the probabilities in a probabilistic way. And actually, people believe this is what's going on in Bing with Bing Chat. When you say like more creative versus more precise is probably just picking the highest probability version, but the more creative one is taking some chances, picking less probable words to try to get like more unusual and unexpected outputs than what we might expect, because if we're predicting most likely word, we might find the most likely choice of fix my laptop to not be as creative as a file ticket to fix my bike, for example. So that's how you generate text from a language model. But how do we actually do this for an enterprise task? Like, for example, summarizing something. Let's say, for example, we have an email coming in, to whom it may concern, best Matt. Well, what they can just do out of the box is, hey, these models are trained to predict, next word. What if on the internet it was like or like in the training corpus there was some, a long email, and then someone said TLDR. What typically comes next is a summary. And so you could just add on the words TLDR and then just use what it was trained to do, predict next word, to end up predicting what is our parental leave policy as the summary of a long email. It was very long, polite, wordy email about asking about our parental leave policy in an email to HR. One example of doing this in Moveworks Bot is smart handoff. For example, given some utterance, like file a ticket to get box, we have to answer the question, which department should handle this if, for example, the forms we offer or the automations we offer do not resolve it, or they click get help to get human help? Should this be handled by IT? Should this be handled by facilities, finance, or do we not know? And should we offer the user all of the options? We call this classifying the domain of the issue. Is this an IT domain issue, facilities domain, finance domain, etc.? And this is actually the kind of thing that language models out of the box often get wrong for enterprise knowledge, because box, looks like a cardboard box. It's the kind of thing maybe facilities will help with. But if you work in IT, there's a software called Box, and that might be the kind of thing that the person's requesting access to. So you could take a generation approach to this, where you, for example, say file a ticket to get box, and then you say, oh, what if we treat this like real text and say new line, question, what department can help? Answer, etc. And this is where we start to see like these language models for long words aren't actually taking the whole word. Sometimes they're like breaking it down piece by piece. And you'll see that actually starts to affect what we get out of it, because the language model might say the is the most probable word. So if you just take the most probable, like we don't get a prediction at all. We just get the word the. What do you do with that? But then if you look at the others, IT, HR, Facila, and this is where you start to see problems too. If one class is multiple tokens, is like if the language model is treating it as multiple words, you can almost do a comparison of the probabilities, but it's like a partial thing. So you have to look at like the probability of facilities versus facilitation. So it might be biased towards facilities by the fact that there's a lot of other ways you can complete the word facility. So it gets a little sophisticated here. And you might say, oh, first of all, you can use constrained generation if you have access to the model. So this is the thing we do is, for example, we would only limit it down to the specific words that would be in the output space, like where we don't care about the word the, we only look at the probabilities for IT, HR, Facila, and normalize it so that those all add up to 100. That's the kind of, and you might think, oh, well, why don't we just for example, throw this into OpenAI API, text in, text out. We don't need to worry about probabilities at all. Well, if you put this into an API, like file a ticket to get box, what department can help? This is a common problem you see when trying to use large language models naively is, you get a really long output. Like to file a ticket to get box, you typically need, if you have a business system, how do you parse this giant piece of text into doing a thing in your program? It's pretty hard. And in fact, it may even produce the wrong answer. Like it thinks box has to do with facilities because maybe it's about a cardboard box, items and surfaces. And you might be able to tinker with it where you say, okay, I just want to output one word and have it be like not in the ChatGPT UI, but it's for example, but then often it will say, for example, like file ticket to get box, what department can help you? And if you keep generating, okay, technical support, but a box, that's not right. And so you can like tinker with it more. And this is the kind of thing called, I guess, prompt engineering, or like basic prompt engineering, where you like say, okay, user query, file ticket to get box, question, what department can help? Options, IT, HR, facilities, other, please answer only one word. And yes, this finally got it to work. But this thing, and this is the kind of thing people are doing. And, it's a way to quickly build something out, but it can be a little bit brittle. Unless you basically take it really seriously and do something called direct classification. And this is what we've been doing since 2019 with large language models, which is you could take this whole representation of the utterance, file a ticket to get box, and that whole sentence is essentially its own embedding or place that's, puts file a ticket to get box, the whole thing close to, I want Zoom, or file a ticket to get, WebEx, or file a ticket to get Dropbox. And what you can then do with that is train a model that doesn't worry about predicting the next word, but just predicts probabilities for the classes you care about. To say it's IT with 95% probability versus HR with 1, facilities with 4. Now, the cost, what it takes to do this, is you need a large data set of labeled examples. For example, typically, at least in 2019, we started doing this, you need over 50,000 of these to train from scratch, under a taxonomy of choice. So if you want to start adding new domains, it's a little expensive because now you have to have examples that include new domains in the output space, because it's kind of fixed to like this specific taxonomy of options that are in the output space. And to do it, you have to fine tune and host your own model, something we've gotten very good at. We have great ML ops and ML infrastructure to host all of these and do collective learning and so on. And the benefits of having all of this that we have in Moveworks is it always stays within taxonomy. You don't end up with it erroring because it predicts the word you or predicts the word the. And it is high accuracy because when you give it tons of examples, it's really honed in on the enterprise language and on exactly what you care about with all the fine-tuned details of, enterprise, of enterprise domains, enterprise departments. So we found that, for example, we tried out large language models like GPT-2 back in the day to just output next text. We found it nowhere near as good as our domain classifier that was specifically trained on tons of data to perform this particular task. We've also found this still does better than GPT-4 at classifying domains within the enterprise. Because GPT-4 is, it's generic, trained on lots of data across the internet, but doesn't really know, like in enterprise, in the tickets that we're seeing, for example, all of our customers, what is the right domain? We've seen this do better. This could also be used for things. So actually, hold on, just to do a quick time check. Okay, make sure we have time for questions. So just summarize this briefly, leave 5 minutes for questions. You can also do this to do query item relevance. So for example, if you wanted to say, hey, you want to have a whole bunch of departments, you want to be able to add new ones quickly, you can have a model that takes in some text representation of the query or the ticket, and also can take in it for a description of a department. For example, our IT department handles hardware issues, troubleshooting, etc. And again, it's like a numerical representation. Models are great at taking numerical representations in and outputting probabilities. So you say, hey, this is like a 0.8, out of 1 similarity, like 80% are related. But what's nice about that is you can improve performance then just by clarifying the scope in your plain text. For example, you could just add to the description, our department handles hardware issues, software provisioning, troubleshooting, and increase the score for queries to get software with no retrain needed. And what's also nice about this type of approach is it works with new departments out of the box. If you train a really good general model that given a representation of a query and given a representation of a department gives a score, then you just plug in a new description of, oh, here's a security department. Our security department reviews all vendor software applications and get something out of that as well. And this is the thing we've been doing with some pilot customers for custom domain. Stay tuned for this in larger products soon. Yeah, it's been a fun thing I've been really enjoyed working on with some teammates on. Also, if you do entities, you can further improve this. For example, if you have a classifier that takes that, like, again, models are good at taking numbers in and doing predictions out. You could take the contextualized embedding for Box and say, hey, that's really close to Dropbox. That's close to like Google Drive. That's close to software, pretty far away from like Cardboard. So we could use a classifier to say Box is probably software in this context. And that specific signal of, hey, they're talking about software, can then, oh, look, software applications can then further enhance a model, and can further be enhanced if you have a database of all kinds of software to verify, yes, Box is actually a type of software that is known, to further improve that score. And this also works for articles. For example, if some query comes in, my VPN is acting up, and you have an article of like, let's say you upload this fresh. You upload this, it gets ingested, and the article has text as title, VPN troubleshooting, description, VPN not working to fix, and so other document features. And again, numbers in, numbers here. We can train on lots and lots of examples, and we end up with a really good relevant scoring model to say this article is pretty darn relevant. 89%, or probably I think it'd be close to upper 90s in our production system to this query. And what's really nice is it also works for paths. So if you've been using Creator Studio, this is what's going on under the hood. Is the user query is coming in, it's being represented, in kind of numerically as close. For example, my VPN is acting up, is pretty close in space to slow VPN connection. And if you, for example, configure your path to have a description of like path description or like troubleshoot VPN issue, and you give a bunch of positive and negative examples, like slow VPN connection is an example of this should trigger the path, troubleshoot VPN issue. Or, there we go. I jumped ahead twice. And my laptop is acting weird, as a negative example. Then all these things come in, and we can, again, use the embeddings to say, hey, this is really close to this positive example. My VPN is acting up, slow VPN connection. But also kind of close in some ways to my laptop is acting weird. Like acting up, acting weird is similar. And so we might get some score of 0.51. And so when you're thinking about, it keeps going ahead. Well, when you think about improving this, the more positive and negative examples you give, and the clearer your description of your path, the better these models can take, can essentially fit and give the right score that you need. So what have we learned today? Large language models aren't just text in, text out. They're predicting probabilities and along the way producing numerical representations that we can leverage. And so if we go back to, for example, here, like a lot of these, for example, domain and tech classification, this was using large language models in this neat under the hood way of like the embedding that's produced. The embedding is produced for classifying the language, for business queries and so on. And, I see we're coming up on the time, so I should hand it back over to Will for questions. But yes, lots of language models, lots of ways to use them, and lots more coming in the future. So questions.
Awesome. Thanks, Matt. By the way, we have another 15 minutes. Today is a 45-minute session.
Oh, great. Okay.
So happy to take time to make sure we get a chance to answer folks' questions. So maybe, Matt, one thing that would probably help is if you could also just provide a quick little recap then of that last slide and kind of everything that you've talked about, just to kind of help get everything summarized for folks that may have been with us the whole time through here.
Okay. This one specifically?
Yeah.
So now, yes. So right. So at the beginning we showed like, we've been using large language models for all kinds of things. Now that you have this kind of intuition of, so if I go back to slides, holding me one sec, it might go forward, of large language models aren't just a text in, text out machine. They're a way of representing text in a numerical way that puts similar words close together, similar sentences close together, along a dimension that you train it to do. For example, if you train it to do this for intent, it'll put similar intent things close together and things that look similar. Like my VPN is actually a good example here. My VPN is acting up and my laptop is acting weird. Out of the box, like for example, OpenAI embeddings will put them pretty close together, but our intent-based ones will actually put them farther apart because the intent of my VPN is acting up. That's a software issue versus my laptop's acting weird is a hardware issue. So as you can actually see, they look a little bit different. There's this is just an artistic, semi-artistic, little drawing of how they look.
Oh, sorry, Matt, you hit the mute button.
Thank you, and thank you. So, for example, here, walking through all the things that Moveworks has in the product of like predicting what's the domain of who to hand off to, what's the intent, like what should we do with this? We use BERT, and I think now Roberta and other things on top of that to basically fine tune a representation of what is like the specific domain or intent, fine tuned on lots of data, and that is using large language models to predict things rather than just taking what the output text is if we sample output text. Triage, that's predicting like which assignment group should come out. That's again using these embeddings to say like, oh, all of these are like this new ticket is pretty close to these other tickets that were marked as support P0. Let's treat it support P0. A generative model for knowledge writing. This was actually our first time just using one of these models to just generate text. Like, here is a ticket. Let's write, help generate an article based off of this ticket. Business queries, kind of more classification side. Translation, that's text in, text out in a different language. And coming all the way up to the present, we've been able to use GPT 3.5 to do what's called in-context language understanding, which is saying, hey, we want to have it do some brand new thing without collecting 50,000 labeled examples. What if we could just, for some brand new thing that we're prototyping out, give it a couple examples in the prompt of what to do? Would it be able to follow that? And the answer is often, not with perfect accuracy, but it can get you good enough, pretty far along for some kind of prototype beta level functionality with things like OpenAI's GPT 3.5. And GPT-4, pretty powerful model, can be pretty good at having much more sophisticated inputs to do things like conversational reasoning. So that's kind of and the nice is this is partly part of why people weren't talking about large language models a lot until recently in the larger field is people a lot of people they just see these as text in, text out, and text in, text out wasn't that great until, for example, H1 of 2023 with GPT 3.5, ChatGPT. But if you know how to use the embeddings, you know how to use the like what it's doing under the hood, you can and we have made use of them since much longer ago in 2019 to power the Moveworks bots that you know and love. And with that, we'll bring it back to questions.
Awesome. Thank you so much, Matt. Great. Well, currently, I don't see that there's any open questions from the audience. So what I'll ask is, if you do have questions, feel free to either use the Q&A module located at the bottom of your screen to ask, or if you'd like, go ahead and raise your hand and I can unmute you so you can ask a question live for Matt as well. During this time, what I'll also do is open the feedback poll for this session. As a reminder, we do have 2 more of these coming up over the next 2 weeks. So what I'd love to do is really get your candid feedback. If you do think that there's anything else that you'd like to hear about this topic, about AI in general, if there's anything else you just want to understand, feel free to give us that feedback in the open text response that's in the poll, so that way we can make sure to include that in the next 2 weeks worth of content. As a quick reminder as well, for the next 2 weeks, what we're going to be talking about next week is the risks around enterprise AI. So considerations you need to think about as you're building out your AI strategy. And then also the week after that, we're going to be talking about the different tiers of enterprise copilot, essentially with the understanding that there's going to be so many more AI offerings that our company and other companies are going to be putting out there in the next couple of weeks and months, how to really think about all of that and what's a good framework for really planning out your overall strategy. So I see a couple of great questions from the audience. So Shuchit is asking, so it all comes down to search algorithm, how the results are displayed. So the better the search engine, the better the results. Is that kind of how to think about that, Matt?
Yes, to some extent. I think so. And I guess in the generative AI kind of world, there's, if you think about the whole pipeline of how do we answer a user query based off of articles. So first of all, yes, there's a bunch of these steps of this. Like one is like from the whole field of like the whole haystack of needles, I guess you could, the whole haystack of which there's one needle that is the article. We need you need a process to filter that down to just the best candidates to look at, because a lot of these large language models, they run fairly slowly. Like, or in other words, if you try to run a large language model to compare the query to every single article in your database, then it's gonna take minutes to answer every single question. So first you need to do some retrieval to with much more lightweight models, bring it down to a smaller subset. Then yes, you need a great search algorithm that can, given some query, given the article text and other features, predict how likely that article would answer the query. Yes, so the better search engine, the better the results. And it's more than just large language models there. There's other pieces that go into it, because of the filtering down from many to the number that your large language model will be working with.
Awesome. Great question. Next one I'll take from Sean, just so that you know, we will be posting the recording for this session, including the slides, onto Moveworks Academy at the end of this week, so you can access it there. Great. Next question we have from Tracy. Hoping I'm following this correctly. It seems as if you understand how to use the embeddings of classifications as it simplifies the process, but they must be fine-tuned in order to, essentially to work properly. Does that make sense? Or am I understanding that correctly? That the fine-tuning step is critical?
Yes, I would say fine-tuning is critical for a number of things. Or actually, so this is where, hold on, let me stop screen sharing for a second to hop to the right slide. So I would say you need to fine-tune if you want to predict under a specific taxonomy that you care about. So let me grab the slide for this. So let me screen share this one. So we talked about direct prediction. Let me actually call one sec and screen share. Hold on, it is not letting me screen share. It will let me screen share in 2 seconds. So for example, here, this is something where there is no model out there that is basically if you go look at open source models try to do a lot of generic things. But for example, directly predicting under the departments at your organization, there's not maybe something out there for that already. So we do fine tune a model to, that basically is this itself, it's a little bit of a simplification here, that it's kind of this outside thing that goes into the model. The domain classifier model is actually itself a large language model that partly produces the embeddings for these words. It basically will the domain classifier puts box really close to Dropbox and pays a lot of attention to it, because that's very indicative of what the domain should be. And so yes, in the process of fine tuning a model, along the way, you get better embeddings. You get the representation of the words that are most important will essentially be put close to other words that is important for doing the classification task. Now, there are, if you want to toy around with this, there are some open source embedding models. I believe OpenAI has an embeddings endpoint where you can send some text in and you get a generic, kind of general purpose, this sentence is generally pretty similar to that sentence score. And that's what, for example, those embedding vector database companies are betting on, I guess. Let's have for example, I mentioned that you could have a relevance scoring model that takes in a file ticket to get box, let's go ahead to the article. Here, for example, query item relevance, and we find really good performance if you have a very specific model that has, takes in the query, takes in all these different features of the article, is trained on lots of query article combinations, saying this is relevant, this is not. And if you want to get something that is for example, a lot of companies trying to that haven't put in this work, that don't have giant query doc relevance data sets to train a really good model, they're trying to bootstrap there to get to decent performance with just out of the box embeddings. Let's just take my VPN is acting up, throw that and get some embedded, some vector in space. Let's take the article and put it somewhere in space. And you do that for all the articles and find the article that is closest according to a generic embedding to the query. The problem is, and these generic embeddings aren't trained for query doc relevance. The language of a query, my VPN is acting up, is a bit different than the language you'd use in an article title, VPN troubleshooting. VPN troubleshooting is article this is text and so our embeddings are trained to take away that, to basically say that to put close together things according to topic, to disregard that oh, this is language article content and query content. We want to put these close together so that this does have a really high score for similar articles, and out of the box generic ones that aren't fine-tuned for that don't have that property. So fine-tuning your large language models does lead to much better, more usable embeddings.
Awesome. Thanks, Matt. Let's see. Well, we don't have any additional questions. So what I'll ask one more time is, if you have any questions, go ahead and ask them. Also, if you haven't yet had a chance to answer the feedback poll, definitely would appreciate about 10 seconds of your time to go ahead and do that. It'd be really helpful for helping us refine the way that we present and also the content that we'll include in the upcoming sessions. Awesome. Well, I will in this, at this time, also make one more plug. We have a events page on our website that I highly encourage folks to take a quick look at, as that includes links to all of the other webinars that are coming up. We have 2 more about AI 101, and then coming after that, we have domain-specific enablement for Creator Studio through the month of July and into August. So a lot of really cool stuff coming up for you. Well, hey, at this time then, I don't see any additional questions from folks, so I think we'll go ahead and call it a day for today. Thank you again so much, Matt, for your time, and thank you everyone for attending. This was a lot of great questions we got from folks. Hope this was really interesting for everyone. I'm definitely excited to go a bit more in depth to the risks of generative AI, as well as your enterprise strategy around all these AI co-pilots in the next 2 sessions. Thank you all. Have a fantastic rest of the week, and we'll see you again next week. Take care, everyone.
Thank you, everyone.